We are due. Forget Yogi Bear. Okay, forget Old Faithful. It's sitting on top of a sleeping giant. It could destroy the United States as we know.
Is Yellowstone gonna blow? That's the question.
Okay, right.
And so
Yellowstone System Alert just reported a massive dome-shaped uplift is still increasing inside. Scientists have found a large dome-shaped rise in Yellowstone National Park, prompting the Yellowstone System Alert. This rise is growing, prompting fears about volcanic activity. The occurrence has drawn interest owing to its possible effects on the park's geothermal features and environment. Scientists and the public are interested in this momentous finding because of its possible effects on Yellowstone National Park. The large dome-shaped rise, still growing, has aroused worries and sparked curiosity about its geological significance and prospective effects. What is Yellowstone? One of the world's most famous and geologically distinctive national parks is Yellowstone, in Wyoming, Montana, and Idaho. It became the first national park in 1872. Background on the park and its geological.
So imagine a cube 6 miles across, deep and high, and that's how much lava came out.
Features. Geothermal wonders. Yellowstone is famous for its geysers, hot springs and mud pots, and fumaroles. Old Faithful, which erupts often, and the Grand Prismatic Spring, with its vibrant microbiological mats, are notable. Yellowstone Caldera. Cataclysmic eruptions built the huge volcanic crater underneath the park. Although uncommon, its supervolcano potential allows for massive eruptions. Geological activity. Yellowstone is one of Earth's most active places. The park's placement above a hotspot, where molten rock erupts from the Earth's mantle, causes geothermal phenomena. This hotspot powers geothermal and volcanic activities. Wildlife. Yellowstone is home to bison, elk, grizzlies, wolves, and more.
Forget the image of Yogi Bear representing Yellowstone. We're talking about a sleeping Godzilla.
Park's geothermal properties give these species distinctive homes. Grand Canyon of Yellowstone. The Yellowstone River travels through a stunning canyon with yellow and red boulders. The Grand Canyon of Yellowstone is famous for its waterfalls, especially the lower falls, twice as high as Niagara Falls. Yellowstone National Park is a stunning natural marvel and a geologically active location with distinctive geothermal characteristics and a history of volcanic activity that continues to fascinate scientists and visitors from across the world. The world's greatest active volcanic system in Yellowstone National Park has been studied and monitored by experts for years. This continuing research seeks to understand the park's geological processes and analyze Yellowstone Caldera's volcanic dangers. The park's unique geology and active
We're talking about a sleeping Godzilla underneath Yellowstone
volcanic system make it a geological research and natural disaster preparedness hub. What is the dome-shaped uplift? The Earth's dome-shaped uplift in Yellowstone is a noteworthy geological event. This elevation is a key sign of volcanic activity. Scientists found and tracked this phenomenon. GPS and ground deformation monitoring. Scientists have deployed GPS receivers and other sensors around Yellowstone National Park. These devices constantly measure Earth's surface points. Over time, they found certain locations increasing, indicating the Earth's crust was rising. INSAR technology. Interferometric synthetic aperture radar may also detect ground deformation. Satellites emit radar signals to Earth and measure ground movement between passes. INSAR data indicate vast Yellowstone regions increasing slowly.
It's sitting on top of a sleeping giant. Now, if you're sleeping next to an 800-pound gorilla, you monitor every burp, every snore of this gigantic gorilla, because when it blows, it could destroy the United States as we know it.
Satellite photography. High-resolution satellite photography supplements ground-based data. By comparing photos from various dates, scientists may spot terrain changes like surface bulges and deformations. Data analysis. These monitoring methods' data is analyzed to develop uplift maps. These maps depict the dome-shaped uplift's extent and pace. Continuous monitoring. Tracking uplift pattern changes over time requires ongoing monitoring. Scientists constantly check data for abrupt accelerations or abnormalities that may signal volcanic activity or seismic risk. The dome-shaped uplift reflects underlying forces connected to magma flow or other geological processes associated with the Yellowstone supervolcano.
Yellowstone National Park could be sitting on a time bomb. There is a supervolcano underneath the national.
This does not necessarily indicate an impending eruption, but it emphasizes the need for continual monitoring and study to better understand the Yellowstone volcanic system and assess its dangers. The dome-shaped uplift in Yellowstone is in the caldera system and is closely connected to magma intrusion into the supervolcano system. This indicates the park's active geological processes. Magma, molten rock from the Earth's mantle, may elevate and alter the crust as it accumulates underground. This magma intrusion is a major issue for geologists. While it does not always signal an imminent volcanic eruption, it is a noteworthy step in Yellowstone supervolcano geological activity. Understanding the amount, pace, and features of this magma intrusion is essential for assessing volcanic dangers and long-term geological history. These activities are constantly monitored and studied by scientists to understand Yellowstone's complicated volcanic system. Why is the uplift significant? The dome-shaped uplift in Yellowstone is important for various reasons and affects the park's future. Volcanic Activity Indicator. The uplift shows that Yellowstone supervolcano system magma is migrating and accumulating under the Earth's crust. While it doesn't always signal an imminent eruption, it's a marker for volcanic activity. Assessing volcanic dangers requires understanding magma behavior. Volcanic Dangers Assessment. Scientists monitor the uplift to determine volcanic dangers. This involves eruptions, volcanic gas discharge, and ground deformation. Researchers can better plan for volcanic outbursts and their effects on the park and neighboring regions by analyzing the uplift. Geological Insights. Yellowstone's geological processes allow scientists to observe a supervolcano system in action. The continuing uplift shows how magma travels and interacts with Earth's crust. This insight can improve a supervolcano understanding globally. Impact on geothermal features. Yellowstone's geysers and hot springs are linked to volcanic activity. Uplift and other geological movements can affect these characteristics. Preserving the park's geothermal environment requires understanding these connections. Long-term geological evolution. Yellowstone will continue to change over millions of years. The uplift helps scientists understand the park's long-term geological development, including the future eruptions and landscape changes. The dome-shaped rise in Yellowstone is growing, which worries experts. This extension suggests that geological processes producing uplift are continuing and maybe strengthening. The pace of uplift growth is continuously watched, and any considerable acceleration might be worrisome. This persistent expansion highlights the need for increased monitoring and studies to understand geological processes. This doesn't necessarily mean a volcanic eruption is near, but the uplift's growing magnitude increases the need for monitoring and readiness. Scientists are actively gathering data, assessing dangers, and updating the public on this dynamic geological event at Yellowstone National Park. What are the potential consequences? The dome-shaped uplift in Yellowstone has various possible effects, which are constantly studied, although they don't ensure a volcanic eruption. Possible consequences include increased seismic activity. Magma intrudes into the Yellowstone supervolcano system, causing minor earthquakes. These earthquakes might occur when the crust responds to increasing magma. These quakes are studied for indicators of growing seismic activity, which might be dangerous, even though most are mild. Hydrothermal changes. Yellowstone is known for its geysers and hot springs. The intrusion and uplift of magma can affect hydrothermal characteristics. It may vary geyser eruption, timing and intensity, hot spring temperature and chemistry, or create new geothermal phenomena. Gas emissions. Volcanic activity can modify park gas emissions. Magma near the surface increases carbon dioxide and sulfur dioxide levels. Monitoring gas emissions is essential for volcanic activity assessment and public safety. Volcanic activity. The dome-shaped uplift indicates the possibility of volcanic activity, although it doesn't indicate an eruption. Uplift, seismic activity, and gas emissions are constantly monitored by scientists to predict eruptions. Preparations for potential eruption scenarios protect park visitors and nearby populations. Terrain changes. Yellowstone's terrain can vary over time because of geological activity. This may include new topography, thermal aspects, and vegetation distribution. Understanding these shifts helps scientists monitor the park's geological development. Animal impact. Park geology and hydrothermal features can change animal habitats and migratory patterns. The park's unique wildlife population is continuously monitored to guarantee its survival. Despite the minimal possibility of a Yellowstone eruption, it is crucial to monitor the situation. Scientists and authorities must monitor the dome-shaped uplift, seismic activity, and gas emissions since geological processes are complicated and unpredictable. Close monitoring provides numerous vital purposes. Early warning. Continuous monitoring detects substantial geological activity changes early. This early warning system gives authorities time to implement safety and emergency response procedures. Science. Monitoring data aids scientific study and knowledge of the Yellowstone supervolcano system. Assessing volcanic dangers, projecting consequences, and making park management and public safety choices need this study. Public safety. Protecting park visitors, local towns, and animals is crucial. Monitoring aids authorities in visitor access, emergency readiness, and public communication decisions. Preservation of unique features. Yellowstone's geothermal wonders are scientific and ecologically significant. Monitoring these distinct qualities helps safeguard them by revealing stability and possible changes. While the chance of a Yellowstone eruption is minimal, continual monitoring is essential for preparedness and safety. It promotes scientific study, preventative measures, and the park's natural beauties and visitors' and residents' well-being. In conclusion, the dome-shaped uplift in Yellowstone National Park, while significant as a part of the ongoing geological processes in this remarkable area, scientists continue to study and monitor the situation closely, prioritizing safety and understanding as they keep a watchful eye on this unique and dynamic landscape. If you found this information helpful, please consider giving us a like and subscribing for more informative content. Thank you.